Hi, welcome to my workshop. I just received a nice package from China. As you can see, this is my first time opening it. We have a nice pouch here. And we have the device itself. It's a portable digital oscilloscope from Finesse. We have a nice manual, which is in English, thankfully. We also have a small USB charger. We have the device here. Let's unwrap it. I must admit, this is smaller than I hope it will be. What else do we have in the box? A micro USB charging cable, a 100 MHz oscilloscope probe. This probe comes with alligator clips. So what's an oscilloscope? An oscilloscope is a device that shows how electrical signals change over time. It displays a graph where the horizontal axis represents time and the vertical axis represents the strength of the signal in volts. It's used by engineers, scientists, researchers, and of course, technicians like us. This very one is the portable type, costing about $70. But there are bench oscilloscopes as well, which can cost hundreds of dollars. Since this channel is mainly about laptop repairs, we can use the oscilloscope to check if our 32.7 kHz and 25 MHz crystal oscillators are generating the proper frequencies. We can also use it to check if the CPU is communicating with BIOS. We can check for glitches in the various power supply lines on our motherboards. We can also use the oscilloscope to show if our voltage regulator ICs are switching properly. Let's look at another use case of the oscilloscope. Laptop charging typically work on a communication protocol called System Management Bus or SMbus. It's a two-wire protocol, namely SCL or serial clock and SDA or serial data. If there is no communication between the EC and the battery on these two lines, the EC will not instruct the charging IC to charge your laptop. Let's see how this looks like on a multimeter and on an oscilloscope.
Okay, let's start first. With the battery disconnected, let's test with the multimeter. First, clock. Let's see the reading. You have 3.3 volts on clock. And let's measure the data pin. We also have 3.3 volts. Now let's connect the battery. Okay, so battery is connected. Let's see what we have. 3.2827. That's clock. Let's see data. Yeah, 3.29 volts. Let's introduce the oscilloscope and see what we have. with battery disconnected. Let's see. Yeah, you can see we have 3.4 volts. Everything is smooth. That is clock. Let's test for the data line. Yeah, 3.36 volts. Nothing is happening. Now let's connect the battery. So battery connected. Now you can see the SMbus communication on the data line. You can see, yeah, that's communication. The battery is charging and there's SMbus communication. Let's check the clock line. Yeah, look at it. So with the oscilloscope, you can actually visualize the communication. You see, that's communication. Yeah, so that's SMbus communication. With the multimeter, you can't. With the oscilloscope, you can visualize. That's the advantage of the oscilloscope.